Hi, thanks for tuning into this episode of QRP to QRO. This is video number 17. My name is Steve, and my amateur radio call sign is KC8QVO. The subject of this video is the Soundcraft UI-24r digital mixer. And if you've paid attention to a lot of my videos, most, not all, but most of my video content tends to be amateur radio related. This is no different. So instead of talking about this in the sense of live sound, pro audio, recording, and the like, it's typical use in home. We'll talk about it in the sense of ham radio and microphone audio and receive audio. There's a lot of nifty things that you can do with this box. If you look at it from the outside, probably if you're an analog guy like me, look at it and think, what the hell is that? There's no switches, knobs, buttons, faders, anything that you would typically recognize as being a control for a mixer. It's really just a black box with the inputs and outputs. We'll cover that in a minute. But where all the magic happens with this one is actually on a website. So you can interface it with any smartphone, tablet, PC, what have you. There's built-in wireless. There's an antenna on the front for it and one on the side. But you also have Ethernet connections. So you can plug into it with a hardline Cat5 cable straight to a computer also. But it's not on the internet, it's just a local network. And then you use a web browser and type in a URL, and then you bring up the user interface. So there's a lot of neat things that you can do in this mixer. So that's what we'll spend most of our time discussing here in this episode, and how you can maximize that for use with amateur radio. Before we get into the mixer, I will talk about the microphone for just a quick second. I've switched over to using a condenser mic. A lot of my other ones, in fact all my other ones, are dynamics. I wanted to try a condenser, mainly for the sensitivity. I wasn't getting quite the sensitivity that I wanted out of some of the dynamic microphones that I have. And in researching it, it seemed like condensers might be the way to go. There's not really any one best microphone per se. It's all really a matter of user preference and what specific environment that microphone's being used for that will point to whichever direction you want to go with a microphone. But in my case, with the other options that I have, I wanted to go with a condenser that was very sensitive. And so I researched them a little bit. And this one's actually made by Roswell Pro Audio. It's a MK47. And Roswell kept coming up as a decent brand for a microphone in this range. So I looked into them a little bit farther and got in touch with Matt over at Roswell. And we discussed it a little bit. And one of the things, a lot of people don't like condenser microphones because they're maybe too sensitive. They can pick up a lot of ambient noise, room noise, and stuff outside a lot easier than a dynamic can. But in my case, I was looking for that sensitivity, and I will say I'm more than pleased with this particular microphone. When I was talking to Matt about it, we were going back and forth a little bit on the sensitivity, and they do have an option that you can get for a higher level signal output. And my thought there was I wanted that higher level on the front so that I was driving everything through the audio chain with a little bit more signal. So just as with anything else signal related, whether it's RF or audio, the higher that you amplify that signal artificially, then typically the more noise that you get. So my theory was if we started with a high output on the microphone, that meant that the gain in the later stages could be lower, and thus any noise that was artificial in the processing would also be lower, because you're not needing to amplify that quite as much as you would otherwise. So that's what we decided with, was the high output on this one, and like I said, it works fantastic. So again, I don't have any affiliation with Roswell, but I'll put a link in the description here also so you can check them out. But very well made microphones. They're actually out of California too, by the way. So it's not an overseas company by any means. So with that, let's move on to the connections on the UI-24. So let's talk about the connections on the box here. I won't spend a whole lot of time with it, but I did want to give a fairly thorough overview of the connections. The first thing that you're going to notice on the box is most of them are the inputs and outputs. Most of them are the 3-pin XLR style. So in the amateur radio realm, you might not be quite as familiar with those. I know guys that run broadcast microphones or studio microphones do tend to use the XLR connectors because they're more of a standard in that pro audio and recording realm. But don't fear them. There's really nothing too difficult about them. It's just a different style connection. Most of the time with receive audio, we're dealing with the 1/4-inch TS or the 1/8-inch TS or TRS style plugs. But there's really nothing a whole lot different other than what the connector looks like in the pinning. And to that point, the adapters, I've made 2 of these so far that I use for mic audio specifically. I've got an XLR on one end for the audio out and the 8-pin round connector for the mic audio going back into the radio. And I'll back up a second with the 8-pin style connections. Some of my microphones and headsets in years past have been from Heil Sound. Let me get that out. There it goes. And if you're familiar with Heil Sound, the way they do their color coding is red is Kenwood, yellow is Yaesu, and blue is ICOM. So since a lot of my other adapter cables for the desk mic and headsets all use that same color coding, I decided to stay with it and keep the same standard. The Yaesu 857 is one radio that uses that 8-pin RJ45 modular connector, but there's other ones. I have mobile radios in the 991 Yaesu. They all use that same style connection. So in my shack, I started standardizing things, and I started going with these 8-pin round connectors, and I pinned them all as Kenwood just to make it easy to plug and play digital interfaces or microphones, or like all these adapter cables for the mixer. I only need one style pinning, and then I can connect it to whatever I want. As far as the RJ45 connector goes, I buy the wires in a pack of RJ45 jumpers. They're 1 foot, so I cut them in half, and then that gives me the molded on RJ45 on one end, and then the bare wire on the other end, so I can put those 8-pin sockets on there. It works out great. That's I've still got several of them left in the back. So I'll put this back together here. So the as far as transmit audio goes, that 8-pin connector is one way to do it. The other way that you can do it is with a 13-pin accessory port, which is what this mess of wires is. So again, 1 pin for Kenwood, which is the red, and then 1 pin for ICOM, that's the blue. And you get both transmit and receive audio on these accessory plugs. If you're familiar with Packet in years past, or any of the digital mode connectors, I'm pretty sure the SignaLink unit, you can buy a ready-made cable that plugs straight into those 13-pin DIN connections. So it's an easy, convenient way. You just got the one cable for the 3 connections, your PTT, audio in and audio out, so you don't have the 3 separate connections. This box, again, it's XLR connections in and out. Obviously, we're talking about the mixer. But inside of it, we have a circuit board. It's a device called an EasyDigi. See if you can see that a little bit better. Now, let me pull this one up. This is another project of mine. It's a little easier to see. But what this is for is isolating your three connections, so your audio in, out, and also PTT. So you can use these as a digital mode interface in and of themselves, or you can use them just as the audio isolation if you want. Say if you have a rig blaster, or I think the Signal Link already does have the isolators built into it, but MFJ makes some. There's a few other variants. But you've got a pair of 600 ohm in, 600 ohm out audio transformers, and then you also have an optical isolator. That's that 6-pin dip for the PTT keying. And the PTT keying, it runs off of RTS and DTR signals from a serial connector, a serial DB9 style plug. So going back to this mess of wires in the EasyDigi, in this box, not only can I use this for the mic audio and the receive audio, but I also have that DB9 for the PTT keying. So if I want to hook this up and run WSJT for FT8 or FT4, I've got everything I need right here with this box, and the USB connection for the UI-24 as being the audio interface to the computer. So really, whether I'm running a microphone for sideband or FM, or if I'm running digital modes, I can use the same box with both. So look at the connections. Oh, we'll talk about the USB ports for a second too. You've got two USB ports on the front. One is record specifically. You can also play back on this, or if you had files on a USB drive that you do want to play back only, you can use that top USB port for that as well. So you may use that, you may not. In my case, like this video, I've got it recording the live audio as I'm going through it. And then of course, as we talked about the USB-B connection, that's so you can get the audio in and out of a computer. And I missed this on the front side, but another nifty trick is these ice cubes by Radial Engineering. It's an XLR connector in and out, but they're line isolators. So there's a transformer in there, and it keeps the audio a little bit cleaner if you've got any interference going down through there. And then you have your ground lift, so you can also disconnect the shield if you have a ground loop somewhere. So I had some audio issues with the line going back to the radio from my microphone audio with a little bit of hum or buzzing in there. And I put one of these on, and it cleaned everything up tremendously. And that's, again, going back to the EasyDigi circuit boards, that's what these two transformers here do, is basically the same thing that the ice cube does. It's just in a different box, I guess. As far as the connections on the side go, there's two Ethernet ports. If you were using this in a pro audio or recording instance, and you did not have enough inputs and outputs, you can use that Ethernet 2 connection to wire up a second UI-24, so you double the amount of hardware inputs and outputs. In my case, I'll never use it, but Ethernet 1, that's the one that you can connect the PC up to. So you can bypass the wireless network and just go straight direct to the UI-24. The two USB ports on the side, if you had a mouse or a keyboard that you wanted to hook up to it, you can actually drive this mixer with an external display going off the HDMI connection, and then you can use the mouse and the keyboard just as you would on the tablet or smartphone, and plug those into the USB jacks on the side. I've tried it. I don't particularly like that interface in my case. I still prefer to go through the tablet, just because everything is, I guess for me it's a little bit easier to go through that way, but you have a lot of options with this UI-24, and that's one of the main things I want to present in this video too, is you do have a lot of options. So it's an extremely flexible extremely powerful mixer, and there's definitely a lot you can do with it. When I was going through the editing of this video, I realized the last section that we talked about connections in left out an awful lot of information. So I'm going to try and go back through and add that back in here. And this section will be a little bit more detailed, so I'll pause here for a second. If you look in the description of the video down below, I do have included a list of timestamps. So if you want to navigate the video at a later date, those timestamps will help you to pinpoint the specific sections that you want to go back to. And also, if you wanted to skip over this section at this point in time, that should help you navigate and do so. So with that, what you're looking at here is a screenshot of the manual for the UI-24 that talks about the inputs and outputs. And as far as the channels that we're mostly talking about, that's 3 through 20 highlighted here in the yellow with a 6,000 ohm impedance. And then the outputs, both the main left and right, as well as the auxiliaries 1 through 8, those have an impedance of about 150 ohms. And also of note, these are balanced connections, both the mic inputs and the outputs, the 3-pin XLRs. So we'll talk about the balanced nature of those here in just a second. I will talk about 1 and 2, channels 1 and 2 here for just a quick second. Those are selectable with a high impedance of 600,000 ohms or 600K. So if you wanted to hook an instrument up to those like a guitar, then you would have the option to switch in that high impedance. But of note, if you are using 1 and 2 without the switchable high impedance, those do set at 4.2K and not the 6K of the 3 through 20. And the TS2000 is going to be a decent example here to talk about. I know we could talk about any number of radios and pinnings and configurations, but with the TS2000 being the main station radio here in my shack, and the 8-pin Kenwood style connections being the standard I decided to adopt in my station. We'll talk about that here for a better example of the radio side of it. So the mic impedance or the input impedance of this radio is 250 to 600 ohms. So if you go back to, again, the output of the mixer being 150 ohms, you do have a 100 ohm difference between the mic impedance here on the low end being 250 and the output impedance of the mixer being 150. So with that impedance being slightly different, the two things that you may notice in that difference would be the dynamic range and potentially a difference in the signal level or the ability to adjust it. So technically, is there a difference? Yes. Will it make a difference in practice? No. You'll see that later on in the live examples that we do. You have plenty of adjustability in the mixer to drive right on through that, and it's really of no concern. So we'll talk about the balanced nature of the connections in just a second, but before I do so, one difference with the 8-pin round connections on ICOM radios specifically, on the mic signal, you'll find that they do have a DC voltage on there. I believe it's a 5 volt or 8 volt DC power that they use for their microphones. So the more appropriate route to get the mixer connected up to that connection would be to use a DC blocking capacitor on your mic signal. So either a 0.1 or a 0.01 microfarad capacitor, like a ceramic disc or a surface mount type ceramic capacitor for DC blocking should be adequate for that. So let's look at the pinning of the XLR connector. And I did draw these up in Microsoft Paint. I know it's kind of cheesy, but that's what I had to work with, and I think it still clearly gets the point across and what we're trying to describe here. So the XLR connectors are 3 pins, You've got pin 1 being the ground or the shield connection. Pin 2 is your mic positive, and pin 3 is your mic negative. Now, one of the misnomers with XLR connectors is because they're balanced, the mic positive and the mic negative isn't necessarily hot and ground or hot and cold. What they refer to is the phasing of the signal. So audio being AC, on the positive cycles, you have voltage above zero or positive, and then on the negative cycles you have voltage below zero or negative. So those cycles above and below zero in that AC wave between pins 2 and pins 3, that signal is actually 180 degrees out of phase. And what's important to note about that is if you have any noise that gets induced along this cable, then because the signal that's going through that is out of phase between the positive and negative, that noise is going to be induced in phase. So when that signal and the noise gets to the device that it's going to, the signal of the noise actually gets canceled out because you have your positive and negative, or your in phase and out of phase signals combining to cancel out any of that noise. It also helps with the attenuation or lower attenuation through that cable. So if you had an unbalanced signal, you would have a lower signal at the end of that cable than you would with the balanced lines. Plus you'd be getting a little bit more noise in there as well. So let's look at the pinning of the XLR going into the 8-pin round Kenwood connector here. Pin 1 on the XLR, again, that's ground or the shield. So that's the green line. We'll follow that down. That goes to pin 8, or the ground for the microphone connector, as well as the chassis and the PTT ground. Pin 2 is your mic positive. That's the yellow line. We'll follow that across. That comes into pin 1, or the mic signal. Then pin 3 of the XLR, that's your mic negative. We'll follow the blue line here. And that goes over to pin 7, or the mic ground. And note that there is a difference between the mic ground and the chassis ground, or the PTT ground down here. So using the Heil Sound example, again going back to their headset adapters and desktop mic adapters, one of the standards that they use is the 1/4-inch TS plug or jack for the PTT keying. So I've adopted that same standard here. The tip of that TS plug, that's the red line. We'll follow that up to the PTT signal on pin 2. And then the sleeve, or the ground connection of that TS plug, that's in green, and that ties in also with pin 8 of the 8-pin connector. So now we'll talk about the EasyDigi circuit board here, and how I've got that pinned into the 13-pin DIN connections, and have the XLR connectors going in and out of it. So this is a blown up picture there of what all you see on that circuit board. And the quality of the schematic that I have for this device isn't the greatest quality. Even the printout that comes with the board is a little bit fuzzy, just like this is. But it should be plenty descriptive for us to discuss this here. So we'll talk about the 8-pin, or I'm sorry, the Kenwood 13-pin DIN or accessory port connection for the first example here. And on the left side we have all the connections that tie back into the EasyDigi. So if we look at the microphone in on the EasyDigi, that's the blue line. We'll follow that across here, and that goes to pin 11 of the 13-pin DIN connection, or the PKD line which is the TX audio in. If we look at the mic ground, and also this, as you can see with the three connections here, on the EasyDigi side, we tie the mic ground, the receive audio ground, and the PTT ground all to the same connection. On the 13-pin DIN connection side, we tie pin 4 together with 8 and 12. Those are all ground connections. Then our RX audio on the EasyDigi side, that's the yellow line. We'll follow that across. That'll get us to pin 3, or the MANO connection on the 13-pin DIN connection on the radio, which is your receive audio level. And on the Kenwood, that's a fixed level. Depending on the radio that you have, you may be able to adjust the level of that in a menu. But once you do set that, it's independent of the AF gain knob on the front of the radio. And then finally, we have our PTT signal, or the PTT high on the EasyDigi. That's the red line. We'll follow that across. And that goes to pin 9, or the PKS signal on the 13-pin DIN connection. So that's our PTT signal. And as with all PTT tripping, basically you just short that to ground, and that transmits, or that toggles the radio to transmit. And in this case also, on the TS2000, that will mute everything on the front panel. So if you had a microphone plugged into it, a desktop mic or a hand mic, when you key the accessory port in the back, then you're not adding in any of that microphone audio from the front panel connector. So now let's look at the ICOM variant. This is also one of the connections that I have on my EasyDigi. But you can hook this up, again, to whichever radio that you want, whatever type of connector it uses, and whatever manufacturer's style pinning that you have. But there is a little bit of a difference here with the ICOM 13-pin DIN versus the Kenwood. So going back to the EasyDigi side, we'll look at the mic signal. That's the blue line. We'll follow that down, and that goes to pin 11, or the modulator input on the 13-pin DIN. And that's your transmit audio. The difference between the ICOM side and the Kenwood side is on the ground. So on the EasyDigi, we tie the mic ground, the receive audio ground, and the PTT ground all to the same connection. But this only goes to pin 2 of the 13-pin DIN. So it doesn't go to any other ones. So if we look at the Kenwood side again, there's 3 pins on the 13-pin we tie together. Whereas on the ICOM side, it is only tied into pin 2. And then finally, the PTT high, or the PTT signal. That's the red line. We'll follow that across. And that goes to pin 3, or the send connection on the 13-pin DIN. And that's our PTT, which when you short that to ground, it enables the PTT, and the same with the Kenwood, is this does override the mic audio going through the front panel connection as well. So now let's look at more detail on pinning the 3-pin XLR connector into a mono or an unbalanced plug, either a TS style plug or otherwise, where you just have a signal and ground. So we'll start with the bare pinning on each side, and we'll bring in the first option of how you would pin this in. We'll look at pin 1, and in this case, what we've done, if we follow that green line down, is we're floating that ground connection. So we're leaving it disconnected at the end of the cable where we're plugging that cable into a device. So in this case, we only have pin 2 connected. That's the yellow line, or the mic signal, or the positive. that goes over to, we'll use the TS style plug for example, that goes to the tip or the signal connection on the TS plug. And then our pin 3 of the XLR, or the mic or line signal minus or negative, that's the other green line here, and that connects up to the ring of a TS style plug, or I should say the sleeve, not the ring, but that's the ground side. And then the other way that you can pin this together is sort of the same. Pin 1 going to, again, not the ring, but the sleeve or the ground connection of the TS style mono plug. And then you also pin in pin 3, or the mic negative. You connect the shield and that mic negative at the end of the mono or unbalanced connection that you're making. So the difference is you have the shielding somewhat through that cable, but again you're connecting that shield back up to the ground in this case. So if you have any induced noise that's on that line, then you're not taking that out quite as much as you would be otherwise. Whereas if you leave that ground or shield connection floating on the other end, you're not connecting that back in. So technically you don't have that ground between both the device that you're going to and the mixer. You don't have that ground tied together. So let's bring in the Radial Engineering Ice Cube just as an example. And the transformers on the EasyDigi work similarly to this. You just don't have the option of the ground lift like you do with the Radial Engineering Ice Cube. But we'll talk about that here for a second. So in this case, pin 1 is the ground, and that's the one that ties into the switch for our ground lift. Pin 2 is our mic or line signal positive, and that connects to one side of the isolation transformer. And our mic or line signal minus connects to the other end of the isolation transformer. So if we look at the device side of that transformer, it's the same thing, that we have our mic positive, or the tip of the TS style plug being our signal. We have that connected to one side of the transformer, and then our ring, or the sleeve or the ground connection ties into the other side of the isolation transformer. So by using the ground lift switch here, we have the option here to either tie in that ground or disconnect it, depending on what type of noise that we have in our application. So a very flexible option to have one of those Radial Engineering Ice Cube devices. And one last note that I want to make on the EasyDigi, if we look at the circuitry here, and I'll back up a quick second, we'll look at the actual circuit board. These orange capacitors are DC blocking capacitors. So we talked about that a little bit on the ICOM radio installations, where you're using that 8-pin connection that has voltage present on the mic signal. If we look at the schematic here, on our microphone connection and receive audio, both of them we have 0.1 microfarad DC blocking capacitors installed. So again, for the ICOM example on the 8-pin connection, with this EasyDigi you already have the DC blocking capacitors already installed. If you're going through the 13-pin DIN connections, it's a moot point really. You don't have that voltage present anyway, but just for the protection on the circuit board, you have those DC blocking capacitors already there, whether you really need them or not, depending on your application. So with that, we'll move into the next section. As we start off to talk on the user interface, I do want to keep this somewhat basic. That's going to be a little bit difficult with all the nifty stuff that you can do with this mixer, but I do want to stay a little bit on the more basic side But I do also want to be thorough with a lot of the different things that you can do, just not going too far in depth. But the first thing that I do want to cover is on the presentation here, this portion of it, I'm using a computer with Windows 10, and my web browser is Mozilla Firefox. As I mentioned before, you can really use any device that you want with any web browser, because all that web browser is doing is accessing the website aspect of the mixer's interface. So everything that you're tuning and tapping into with the menus and settings and all that is on the mixer side, but the pathway to that is through the website, and any web browser will get you there. It doesn't necessarily have to be an iOS device, a Windows PC, or an Android device. It can be any web browser. So there are two ways that you can connect up to the mixer. One is wireless and one is the Ethernet connection. And for this presentation, I am using the wireless. So we'll go ahead and note that here with my wireless connection. Oops, I didn't want to take that off the toolbar here. Let me put that back in. There it is. But here we have the Soundcraft UI-24r network connected. And again, it's just a local network. It's not going out to the internet, so it's just between my computer and the mixer, no external connections. Then we'll go out to the web browser, and the URL that we type in is 10.10.1.1. And as we start loading that user interface, you'll see that we have two options. One is the large format, which is what I'm going to use for the presentation. And then you also have a small format. So if you're using a smartphone, that screen obviously is noticeably smaller. So the information that's contained on that screen needs to be in such a size that you can actually see it and work with it. But again, the large format is the one that we're going to use in the presentation. Really, the menus and everything are pretty much the same. It's just the size as to how things show up on the screen that changes between the two. We'll go ahead and load the user interface, and now we're in the live mixer. And you can see the signal meters here. Channel 11, again, as we were talking in the connections portion of the presentation, that's my mic channel, is 11. That's the first of the XLR inputs that are only XLR inputs. Channels 1 through 10 here have both the XLR and the 1/4 inch connections. So the first page that we come to is the main mix, and as you can see on the bottom, it goes up through channel 13, and then on the far right you have the master level adjustment. So to adjust this, or to change the positioning on the screen, in my case, again using a computer with a keyboard, I'm using the left mouse to click and hold, and then I can slide the mouse over, and then that lets me drag that screen over to all the other adjustments that you can do within the main mix. So a few of the things to note, again, channels 1 through 10 are the combination XLR and 1/4 inch connections. Channels 11 through 20 are the XLR only. Channels 21 and 22 respectively are the RCA connectors on the front of the mixer. Channels 23 and 24 are two phantom channels. I won't get into phantom channels too much, but you can change the pathways that different channels, outputs, and submixes get linked together within the software of the mixer. And those 23 and 24 channels are so you can link back to the main mix with one of those phantom mixes. Line in left and right is the link from the computer. So if you have the USB connection to the USB-B port on the front of the mixer, and you're playing audio out in 2-channel stereo left and right, this is where that sound comes into the main mix that you're playing with on the mixer. Player left and player right is the USB port on the front. Again, that's the one that's not the recording port, so it would be what would be the top of the two conventional USB ports. This does have 4 internal effects processors built into it. I won't go over the effects too much, and by effects I mean echo, reverb, things like that you'd use more in a musical sense than you would in radio, in communications at least. Then you have 6 submixes. So if you're familiar with larger format console mixers, these are basically doing the same job as what the submixes would do on a larger format analog console mixer. So you can do that digitally here with the linking and the pathways between all the different channels. You have that same type of flexibility and beyond with the UI-24. Then you get into the auxiliary outputs. These are, it has 8 hardware outputs on it, and then it has 2 extra auxiliaries. And again, going into phantom channels, you have 2 extras that you can use in various capacities, whether you want to link those back into channels, say 23 and 24 on the main mix, or if you want to link these back into, say, a submix. You have all kinds of flexibility in how you link all that together. But the other thing that you can do is you have the master left and the master right outputs on the front panel as well. So in theory, you could change those master left and right outputs into auxiliaries 9 and 10 if you chose to do so. Again, that's getting a little bit deep into it, but another aspect of those left and right outputs is it's not just XLR on those. You also have the 1/4 inch unbalanced TS plugs that you can use as well. So again, just a ton of different options in this mixer. Now, if you're familiar with console mixers, there's on each channel there's 2 different level adjustments. So the fader, most mixers, they do use faders, the bigger ones anyway. Some of them the small format ones, some of them do use the smaller potentiometers. But the main level control that you have in that live mix would be that fader control. However, you do also have a gain adjustment, and all the mixers that I'm familiar with have that as a potentiometer. Because of everything that is on this screen, they hid the gain adjustment. That's in a separate menu here in the second function of the mix/gain button on the top of the screen. So we'll toggle that to the second position, and now we get into our gain screen. And again, I'll use channel 11 as an example because that's the microphone channel, and because it's a condenser microphone, we do have our 48 volt phantom power turned on. Now, one of the things that I want to point out in this particular screen is, again, if you're familiar with the console mixers, most of the time, unless you get a real high-end, very large format mixer, most of the time you have a switch either on the front panel or the back panel by the power cord that allows you to enable phantom power, but that turns on the phantom power across every channel on the console. So with this mixer, you can come in here and say channel 10 had a condenser microphone also. Channel 9, we'll turn on that. And then maybe channel 6 has a condenser mic. You can toggle this independently depending on which channel you actually have a condenser microphone on. So you don't need to enable everything under the sun. It's just specific to whichever channel that you have a condenser microphone hooked to. Something I won't touch on too much, but again, this pertains more to a musical use of the mixer, but you can toggle channels 1 and 2 to a high impedance on the input, and that allows you to plug an instrument like a guitar straight into the mixer, and you can use this as a standalone guitar amp if you wanted to. So we'll go back to the main mix screen here, and so we'll dig into the microphone channel a little bit further here. So we'll go ahead and highlight that. Oh, another quick thing on the main mix too. I'll use channel 12 as an example. You can customize the labeling in here. And let's see if I can get into it. There we go. So it has an option in here that you can go in and rename what that channel is, so that you can more easily and quickly recognize what that is, and not necessarily just the number. But in this case, that's the receive audio when I do have it connected to the 718 ICOM radio. I've got it unplugged at the moment just for the video. But you can go in here and you can customize these to whatever you want to have those say. Again, this one's the TS2000 receive audio. So just a lot of flexibility. While we're on that subject too, and I'll use, if I can find one, channels 21 and 22. If you see this little triangle, that lets us know that those are linked as a stereo pair. So you can do that with any set of channels. So we'll go to 19. We'll turn 19 and 20 on as a linked stereo pair. So now we have 19 and 20 linked together and they move in sync. I'll go ahead and disable that though, because I don't particularly want that on the main mix at the moment. Let's go back to our channel 11. Again, that's the microphone. We'll go up to the edit button and we'll get into more of the fancy stuff that you have available in here. And we'll start off with the equalizer. And I won't get into the tuning of it too much. That's going to be in a separate segment. But we'll just go through a quick walkthrough of some of these options here. The RTA on the bottom, that's your spectrum view. So as you see, the spectrum is corresponding to the audio that's going through it. We have it on the basic or the easy EQ. That's this button down here on the bottom left of the screen. And we have 3 bands that we can adjust in that. If you disable that, you get into a lot more flexibility in what frequency ranges, etc., that you want to adjust. And we'll get into that a little bit deeper here in a minute. The noise gate, I do have that turned on, and that's a really nifty feature. And again, this is on every channel, so all of these that we're going through on the top here, the equalizer, the gate, compressor, all of this is adjustable and savable, I should say, to each channel that you have in the mix. So you don't need a separate box for each one of these options. You don't need to route the audio out of a auxiliary port on your mixer and then back in to get your equalization, your gate, compression. All of that is built in digitally into the UI-24. And going back to the condenser microphone being extremely sensitive, that's one of the reasons that I do have the gate on. If you see these 2 little green arrows on the meter, that's the set point of the gate, or the threshold. So right now it's at minus 34.5 dB. So we'll go ahead and toggle this slider back, and you can see these arrows dropping down as I slide that, so now we're at minus 60.8. But you can play around with this with whichever microphone you have and whichever environment that you have, and you can increase the set point so that your microphone is not passing audio until a sufficient amount of audio goes into it. So in between when you're talking, if you have background noise in there that you don't want going out the microphone, then you can come in here to the noise gate and you can adjust that. And that will allow it to be a lot more quiet in between what it is that you're saying. So I forget what that number was I had it set to, and it's not really all that important in my case. We'll just put it at minus 41. That'll probably be fine for now. The compressor I'm not going to talk about too much, other than you do have that here. If you use a hand mic or a desk mic, I guess, for that matter, one of the things that you might notice is that your distance from that microphone will change what the drive level is of the audio, and this can come into play. Speaking of radios anyway, the more you fluctuate that audio, then the higher or lower the drive might be to the transmitter. And of course, if you're using an amplifier, the transmitter drives the amplifier, and so on and so forth. So by using the compressor, you can balance that audio so that your distance from that microphone doesn't play with that drive level quite as much. And you'll notice that just strictly speaking of audio also, and the volume, you'll notice that, with any microphone really, that the further away from that microphone you get, the softer the audio gets. Pretty much, that's a given. But if you adjust this compressor, you certainly have the option to adjust it anyway, to tune that audio a little bit in your particular environment. The effects, I won't get into that too much. Again, that's things that pertain more to music than they do radio. The auxiliary sends, again, we covered that a little bit. This allows you to change the drive level within the channel to the auxiliaries that you have it going to, as opposed to the other way around. So you could go in here and select whichever auxiliary channel you want, and then you can go to the main mixer and adjust the drive level for that channel on the auxiliary. But you also have that available to you within that channel itself. You have all 10 of the auxiliaries selectable. The patching, I won't get into that too far in this particular segment, but again, you can route that channel digitally to other areas within the mixer. And let's see, let me go into, we were talking about the different formats of displays. So let me go into the local settings over here, and we've got an option in here that has, or that says big desktop mode for mix. So if we toggle this, let me go back to the main mix for a second. So if you look at this one, all we have is the main mix. So again, if you need to adjust the gain, you have to go into a separate area of the mixer. If you want to get into the equalizer, for example, you have to go into yet another area of the mixer. So hold that thought, and we'll go ahead and enable big desktop mode. And it's going to reload the user interface. And now we have big desktop mode enabled. So again, it really clutters up the screen. One thing I didn't cover was the meter display, but it also adds that into the top of the screen here that you can see. But now it has all of these different windows enabled that you can see all at once. So if you have a big enough display where you can shrink the resolution of your screen down to where all of this fits in there nicely, then you can have all of this information to you available to you in one glance. But again, as you see on my screen here, it definitely does clutter things up. So we're going to go ahead and disable that, go back to the basic display mode. And this display mode again is the same that you would get with any tablet. So if you go into that initial user interface selection window, in fact we'll go ahead and do that if I can get it to reload. There it goes. In fact, we'll go ahead and try that. Let's go to the small format so you can see what that looks like side by side. So we'll go ahead and scroll across that screen a little bit. But as you can see, everything is a little bit more exaggerated. So if you saw that on a smaller screen, you would have the full range of that fader available, and it'd be a little bit easier to adjust, etc. If we go back over to the big display, everything is a little bit more condensed, if you will. And just because I'm doing it in this particular segment of the video, I am recording live to that USB on the USB thumb drive on the front of the display. So every time that you save the recordings, this recording wizard, I'll call it, is a little bit basic. There's not much that you can do other than enable the recording and disable it, and then play it, stop it, pause it. If you do go in here, I don't know if it's going to let me do it. I don't think it is while it's recording live. But there was supposed to be a tool that they had where you could come in here and rename the file. But unfortunately it does not work. So the only way that you can go back through these files is on the computer. So you have to pull that USB drive out, put it in the computer, and then you can work with it on the computer side. But when you do bring that file back in, if you do have sound files that you want to play back, and they have been renamed on the computer, you will see those names show up here, not just the coded ones off the mixer. We'll talk about multitrack just for a quick second, but you can come in here and record specific channels. Yeah, there we go. So again, there's a bazillion different ways that you can route this mixer. But if you're familiar with audio in the sense of music, say you have a 5-piece drum set, a guitar, and a vocalist, you can come in here and record individually all of those 7 channels. So your 5 drums, the guitar, and the mic for the vocalist, those could be 5 individual channels. Then you could record those individually and then mix them on the computer later on. So in a ham radio world, would you ever use that? Maybe if you want to record the mic audio and the receive audio as 2 different tracks. There's some things that you could do there if you wanted to, but it is interesting stuff to do. So let me go back to the meter view because I bypassed that except for the big display mode. But this is what it looks like on the, I'll still call it the large format display. It's not the big display mode, but it's the, between the tablet and the smartphone, this is the bigger of the 2 views. So that pretty much covers it for the user interface side of it. So we'll move on to the next section. So we're back in my makeshift studio, and I'll go over a few of the connections, etc., before we get into mixing the audio and playing with the mixer. First up is I am using this Heil headset. and the microphone on it. That way I don't have any feedback from the speaker into the microphone. So I'm listening to the mix live on the headphones. That's the same exact audio that's getting recorded for this video. That's what is being saved to the USB drive as we're going along. Yeah, as far as the feedback, I just didn't want the speaker messing with the sound going into the microphone. So I'm just using the headset instead. The radio that we're using is the ICOM 718, nothing special. And we're using, if I can get this spun around, we're using the 13-pin DIN connection on the back of the radio for the interface back to the mixer. Get that back on there. So the audio from the 718 is going through my Easy Digi box down here, which I haven't put the lid on that yet. I was trying to do some troubleshooting with it a little while ago. But the audio from that is coming into channel 12 on the mixer. And then we have also the service monitor. That's an Agilent 8935. I have it set up for two-tone generation. So we have 800 hertz and 2 kilohertz. I'll put a close-up on the screen too of the settings on that. So we have the mixer coming into, or I'm sorry, the service monitor is coming into channel 10, the 1/4 inch. I've got it coming out a BNC, the audio out to the 1/4 inch input there on channel 10. And then the other audio source that we have is from the laptop. And I am doing a screen recording video at the same time, so I have 2 video sources. I'll mix those together in a minute. But we're using a software on here called Jakarta, and I'm using that as a white noise signal generator so that we can play around with some of the filtering, etc. on the UI-24 interface. So let me go ahead and give you a sample of those audio sources here. And another thing too, I'm using this tablet as my control, and then the laptop is only going to be for the monitor, because I want to leave it on the spectrum view there with the parametric equalizer. So we'll go ahead and turn on our white noise. And we'll go ahead and turn on the receive audio from the 718. And then we'll turn on our two-tone signal injection. You can see those coming up on the spectrum view in the parametric equalizer. So when we're talking amateur radio, we're talking voice communications over radio. So where you have the most challenge of intelligible audio is usually on single sideband. If you're familiar with AM also, you do have a lot of that white noise, that noise that you have in the background. But on sideband, that's usually where we have the biggest challenge with making out voice signals over top of the noise. So if you're trying to work a weak station and you have that background noise competing with that signal, sometimes it can be very difficult to make out what it is that the person on the other end of the radio is saying. So that's what we're going to try and tune the best here with the equalization on the UI-24 mixer. So to sample that, we'll go ahead and bring in the audio of the ICOM 718 just as a sample. So you can hear how much static there is in the background versus the signal that's in there. And you also have that miscellaneous tone. Of course, that's somebody tuning up. That's pretty rude to do on the ham bands, but nonetheless, it happens all the time. And there are also different signal sources that cause those types of tones that we commonly refer to as birdies on the ham bands. So we'll talk about tuning those out as well as we go along. So we'll go ahead and turn that off. And what I'm also going to do is, at the moment, I have my microphone signal coming into the spectrum view on the screen. But I'm going to go ahead and pull that off so that we can leave the equalizer off of my mic audio for a minute. I'll go ahead and switch this around. And if I set things up correctly, you should still be able to hear me just fine. And it looks like that worked. So we'll go along with it here. So if you get into studying audio and frequency ranges, etc., one of the things that you'll likely come across is a study done by Bell Labs. There's a couple guys, Fletcher and Munson, that did a study on how humans perceive the loudness of sound. And the results of that study are in their chart, commonly referred to as the Fletcher-Munson equal loudness curves. So what you see in this graph is, and I'll back up a second, human speech, intelligible audio, is typically in that 1 to 3K, 1 to 3,000 hertz frequency range. So what this chart is telling us is that how humans perceive the loudness of sound. So we'll take right here in the middle of the mid-range, we'll say 1500 hertz is what we're comparing to. And if you look at the chart, that lies right about 5 dB. So if we compare that 1500 hertz or 1.5K signal to, say, 50 hertz down here on the left, a low frequency, then at 50 hertz, that sound SPL, or pressure level, for it to be perceived at the same loudness of 1500 hertz, it needs to be all the way up at 40 dB. So we have a difference of 35 dB in the sound pressure level to perceive a 50 hertz signal at the same apparent loudness as, say, 1500 hertz down here in the mid-range. And as you go up in intensity, you'll see that these curves flatten out, which we're not, in radio communications, we're not talking very high sound pressure levels. We're not concerned with being able to be heard over a screaming crowd, with a band playing and trying to get over top of the audio of the people screaming. So what we're just trying to do is get a comfortable listening level with intelligible audio from the stations that we're trying to work on the radio. So we're working, of course, down in these lower signal levels. So with that having been said, let's go ahead and bring in noise. And I need to correct myself a little bit. The noise generation that we're using actually is pink noise, not white noise. Although when you listen to sideband or an AM radio, that hissing noise in the background is commonly referred to just as white noise. But technically speaking, that's more high pitch and frequency than is pink noise. And when I bring that on here on the spectrum view, you'll see that pink noise is more uniform across the spectrum. So that's why we're using it here, just to give a very balanced noise source that we can play around with here. So now we have our pink noise in the audio stream. And again, my microphone audio isn't going through this at the moment. We can pull it in later, just as an example, but I'm going to keep it out because we're going to play around with the tuning of this for a minute. So again, intelligible speech being centered over, say, that 1 to 3K range. I've preset one of these points on our parametric equalizer centered up at about 2.5K just as a sample. So I'm not going to change the level of the noise in the background, but what I am going to do is decrease the level specifically at that 2.5K frequency point. So as I bring this down, you're going to notice that my voice tends to pop out over top of the audio, more so than it was before. So the opposite is true also. If we amplify the noise above, then you'll see that my voice is a lot more difficult to make out over top of that noise. So the long and short of what we're trying to do is create the most intelligible audio that we can. So let's do something a little bit different here. So we'll keep this, we'll drop that down to say minus 10 dB on the attenuation. So let's come over here to our low frequency. We have that set at 40 Hertz. So if we amplify this, again we're increasing the sound pressure level at that 40 Hertz, or roughly around that 40 Hertz range. You're going to notice that that comes up, and depending on your speakers, you may or may not hear this. If you're using headphones, you might, or if you're using a higher quality sound system, you may be able to make out the increase in the bass in the background. But what you'll also notice is that the intelligibility of me speaking doesn't necessarily change. So we're going to go ahead and do the same thing on the high frequencies. Now this isn't going to be necessarily pleasant to listen to, but we've increased both the low end and the high end by 20 dB, and the intelligibility of me speaking amongst all that noise is still very clear. We'll go ahead and back these down again. Drop those back down to 0. And just to go back to the point of the mid-range being mostly where the intelligible speech range lies, let's go back to our mid-range here. That's point number 3 on the parametric equalizer. We'll go ahead and bring that up, and you'll notice that as that noise level goes up, the intelligibility of me talking starts to disappear down in the noise. So now let's bring in an active QSO, listening to 40 meter sideband at the moment, and we'll apply the same theory of the mid-range frequencies being where intelligible audio lies. We'll apply that that we just walked through to an actual on-the-air signal. So we'll go ahead and turn on the audio from 718, and there's our signal. And one thing to note about the 718 is there is no audio processing on it. It's a base model. I do have the UT106 noise reduction in it. However, it is not enabled at the moment. So the only thing that we have turned on is the preamp. And just to prove the point also of the basic audio, or the basic functions of the 718, I do have the IF shift centered. So we can go ahead and sweep that a little bit so you can hear what effect that has on the audio also. Go ahead and turn it up here. So that's another tool that you can use. Change how easy it is maybe to hear signals on the radio. So if you have somebody that's down in the weeds above the frequency that you're operating on, or I should say causing more of a high pitch sound. Again, if you're on upper sideband or lower sideband, the frequencies go opposite each other. But we're strictly speaking of the audio realm here with the equalization, etc. So that's the frame of reference with the higher frequency there. But you'll also hear one of those whistles in the background, that noise that's a single tone that's slowly going down in pitch. So it's just one of the noise sources that's common on the HF bands, on sideband, that you have to deal with. So let's look at our mid-range frequency here. We won't change anything else on the audio spectrum, but just that mid-range. We'll go ahead and pull that up about, say, 10 dB. You'll notice that the station that we're listening to comes up out of that noise a little bit more. And of course they stop talking. There they are. And then we'll go ahead and back that back down to 0 dB and balance it out. So you can hear the intelligibility of that station isn't quite what it was with the amplified mid-range. So another nifty thing that you can do with the parametric equalizer on the UI-24, and I'm going to bring the number 1 point up a little bit. I'm not really going to use it right now. I'm just moving that up, and then at number 4 I'm going to bring that back. We may use those a little bit later. But the high-pass filter is what I want to get to next. And at the moment, we've got that all the way down on the bottom, but we're going to slowly bring that up. And what I want you to notice is with the high-pass and the low-pass filters, essentially what we're creating is a bandpass filter. Again, this is all in the audio domain. It's not in the RF domain, as you would see with IF DSP in some radios, but we're strictly dealing in the audio domain. But there are a lot of radios that do have bandpass filtering, both IF and audio, that you can tune. Going back to the 718, or I'm sorry, the 857, the Yaesu 857 radio I have. It does have the variable audio filtering built into that, but the 718 does not. But we can sample that or simulate that right here within the parametric equalizer. So we'll go ahead and tighten up the filtering here. So I'm going to set the low, we'll say, down about 300 hertz. And then we're going to set the high side, or the low pass filter. We're going to bring that down to say about 4K. So now between that 4K low pass filter and the 3K high pass filter, we have about 3700 hertz or 3.7K of audio bandpass to play with. So we'll go ahead and bring in our audio tones from the service monitor here. And we're not just going to bring one in. We'll make it a little bit more complicated, and we're going to bring 2 tones in. I can find them. Which channel is that on? That is on channel 10. So there's our tones. We'll go ahead and leave them at that level. I think that's... I know it's not pleasant to listen to at the moment, but it's not overbearing either. So if you remember right, we've got 2 tones. We have one at 800 hertz. So we'll go ahead and set number 1 to about 800 and get it on there. 815, that's close enough. And then our other tone is at 2K. We'll select number 3, and we'll back this down to right about 2K, if we can get it there. 2.02, close enough. So let's look at our 800 hertz birdie tone in the background for a second. If you take the Q of the setting here for the equalizer and you run this all the way up, you're going to tighten up the response of that setting. So we're going to go ahead and drop the gain, and you'll notice that that 800 hertz tone disappears. And we'll do the same thing for our 2K, which you can still hear in the background. We'll take that Q, go all the way up to the top, and then we'll take the gain, and we're going to attenuate it, and we'll knock that tone pretty much right out. See if I can rock that back a little bit. Yeah, so our 2K tone is out, and we'll come over to our 800. I can still hear that just slightly in the background. See if I can move that around and get it out. Yeah. Well, let's back off of the Q just slightly. So now we've pretty much got our two birdie tones eliminated from that audio stream. So now let's use point number 4. We're going to drop this down to say 2.5K or thereabouts. We're going to try and bring out the signal in the background that we're listening to, the voice. And you'll notice that that signal now is a little bit more clear to listen to than it was just a second ago. I'm also going to back off of the Q a little bit with the 2K tone. We can widen that up a little bit. So the overall sample here, or example, is we have two birdie tones over top of the live signal that we're listening to, but by manipulating the parametric equalizer, both with the bandpass, or I should say the high pass and low pass filters, creating a bandpass filter, as well as using a couple of the points on the parametric equalizer as notch filters, we can bring out the intelligibility of the audio of the station that we're listening to. We'll go ahead and turn off the tones. And now we'll just play with the raw audio one more time. So those notch filters, we'll go ahead and disable those. We'll bring those back to 0. And then our point number 4, which is the amplification of the mid-range, we'll go ahead and drop that back down to 0 as well. And you'll see that reduction again in the intelligibility of the signal that we're trying to listen to here on 40-meter sideband. And if we boost that gain a little bit on the mid-range, you'll see how that signal rises pretty well up out of the noise. And then again, the way that everybody hears sound is different. So it's, again, one of the blessings that you have with all the flexibility in the parametric equalizer is that you can tune it to what is most comfortable or most pleasing for you to listen to, and not so much necessarily overpowering a particular frequency range, but you have the adjustability here to tune that signal to how you hear it best. So let's do another example here. We'll go ahead and select the high pass filter or the low frequency side, and we'll pull this up a little bit so we can see it. We'll do the same thing on the low pass filter or the high frequency side. We'll pull this down so we can see that as well. And on both of these, we actually have three different adjustments for the sharpness of the slope of the cutoff. We have 12 dB, 24 dB, and 36 dB. And again, on the high pass filter side, we have the same 12, 24, and 36 dB options. So for this example, I'll go ahead and tighten this up to, on the high pass filter side, we'll turn this up to about 500 hertz. And the low pass, we're going to set this down to about 4.5K. If I can get it there, it's kind of touchy. And 4.45, that's close enough. And then number 2, I'm going to use that as our mid-range, sweepable mid-range. I've got that set to 2K at the moment. So we'll go ahead and boost this to about 5 dB. And I'm also going to bring up the level of the receive audio from the 718. So we have a little bit more audio in the stream to play with. And going back to the differences and how individuals hear sound, we'll go ahead and sweep this a little bit on the frequency, the center frequency, and you'll hear how that changes the pitch and the intelligibility of the signals that are there that we're trying to listen to. So again, we're at 2K now, bounce it down to about 1.5K. We'll go ahead and turn it down to about 1K. We'll go to 2.5K. We'll go up to 3K. And now I'm going to decrease the Q and widen up the response. We'll drop this back down to a Q of 1. And I'll just sweep this all the way down to 1K and then back up slowly. You can hear how that changed. So where I hear that the best is anywhere between 2 and 2.5K on the center frequency. And again, the previous example was right at 2.5K. And we'd increase the gain up to 10 dB now. We'll go ahead and sweep this up in frequency. And we'll go ahead and drop this down below 2K. So again, just by changing the mid-range response, so I've got that set to about 2K right now, and like I said, anywhere between about 2 and 2.5K for me is what helps out the most with bringing out the intelligibility of that signal that we're listening to. And I'm going to drop the level there of the 718 so I can talk over it for a second. But anywhere between that 2 to 2.5K for me, again, is where I hear that signal the best. And again, the important thing to note here is that you do have all that flexibility with this EQ, both that sweepable mid, and then we also have the ability to tune these high and low pass filters as well to get that frequency response where we want it to better assist us in listening to and making out those signals that we're trying to listen to in the background. So very flexible tuning here within the UI-24 parametric equalizer. So now that we've talked about receive audio, let's talk about transmit audio. And of course, if you're trying to work a DX station, you can't just unplug your microphone from the radio or the mixer and plug it into the DX station's ear canal. But there are a few things, going back to speech intelligibility, there are a few things that you can do to help out that signal as it's coming across your radio to the other stations. So, as we've already talked about, the mid-range frequencies being 1 to 3K, being most important to the intelligibility of speech, we can use that to our advantage on the transmit side with our microphone. Now, a couple things to point out. Of course, you do want the cleanest signal that you can get from your microphone going out to the radio. So if you have any other noise in the background, trying to eliminate that is going to be the best thing. Or if you have any hum, going back to the Radial Engineering Ice Cube isolators or the Easy Digi isolator, the transformers that circuitry has to isolate your audio. A lot of those tricks can be used to clean up your transmit audio. So of course you want to start with the cleanest audio signal that you can going into your transmitter, and then you can play around with the equalizer. So to simulate noise in the background, the cooling fan is running on this service monitor. So if I can get close to it here, you'll notice that amongst my noise or my speaking in the background, you'll hear that fan noise, and that all goes right through the microphone audio. So if you can eliminate a lot of that sound up front, then you won't have to worry about all of that noise competing with the signal that you're trying to get across to the other station so that they can hear you more clearly. So let's go ahead and pull in a bare signal from 40 meters. Just as an example, this will give us a sample of band noise that we can compete with and adjust to. And again, this is coming off of the ICOM 718 without any processing other than the preamp. And what you'll notice up front is we do have the band noise, the typical band noise, but we also have that constant tone birdie in the background. So let's use this as the same example we had with the two-tone generator from the service monitor. And because this is a live signal, it gives us more to adjust and play with in I guess, a worst-case scenario. So hopefully the station that we're trying to work isn't actually sitting there in this frequency on the band that would have that birdie, or they may have a notch filter enabled to where they can take that out. But let's leave it there for the time being. Again, just to give ourselves a worst case scenario to play with and adjust. So we'll go into the EQ for the microphone. Again, I don't have my microphone going through the chain that is represented in the spectrum view that you see on the screen. That's just showing the receive audio.
And I'm also not transmitting live. I'm just overlaying my audio and the receive audio from the 718. So there's no transmitting from me to the 718. It's just the audio overlay. But you can get the gist of what we're trying to accomplish here by looking at the signals here. Let me go over to, in fact, I'll do this on the computer side so you can see exactly what I'm doing. So we'll come over to the main mix screen, and we'll go over to channel 1, or I'm sorry, channel 2. That's the one I'm using for the Heil headset at the moment. So we'll highlight that, come into our edit screen, and now we have our parametric EQ, and we'll go ahead and enable the RTA, or the audio spectrum view, here just for the microphone. And just to show you what we're doing here, we'll go back to channel 20. That's our audio that we're really playing with in the bulk of this video. And you'll see if we enable that RTA, we have just the audio there from the 718, our 40 meter band noise. We'll go back out to the microphone channel. Actually, I tell you what, let me amplify the sound from the 718 real quick, just so we can. Well, I tell you what, I'll leave that alone, and I'll attenuate the microphone. We'll go that way with it instead. We'll come over here to our level. We're at 10 dB, and let's see what 5 dB gets us. There, as best I can tell in the headset, that should work out fine for what we're trying to accomplish. Now we'll go into the parametric EQ for the microphone. And again, going back to intelligible speech being around that 1 to 3K range. We've got point number 2 on our parametric equalizer set to about 2.5. It's at 2.43, but close enough for what we're trying to accomplish, and we can swing that back and forth also. But again, one of the important points to really reinforce is that you want to have clean audio up front. So the mic audio, as well as any hum and interference that's going through the cable and out the transmitter, you want to clean that up as best as you can, because all that noise does is decrease from what you're trying to accomplish with being heard. We'll take this mid-range, and we're going to amplify that a little bit. And as we come up to, say, 10 dB, you'll hear the intelligibility of me speaking coming up, and my apparent loudness is also coming up quite a bit. And that's exactly the point that we're trying to drive home here, is as that mid-range is increased, the talk power now that we have over that band noise, and also that birdie, the constant tone that you hear in the background, we're taking that ability of my speaking being able to be heard and increasing that over top of all that other band noise. So conversely, if we drop this back down and we go down to 0 dB, which we have, of course, the microphone element doesn't have a flat frequency response by default, but if we look at the spectrum view and where we have the equalization, it's flat. The equalization that we have set is 0, so there is no equalization, artificially anyway, over top of that microphone signal. But if we do artificially take that mid-range again and amplify it, as I'm doing as I'm talking, you'll notice that the ability of me being heard over top of that band noise comes right up out of the noise. So it makes a huge difference. Again, you need to, going back to the transmitters and gain, you don't want to be overdriving the audio going through your radio, because if you do that, then you distort the transmitted signal. So that's another thing that you need to be aware of. But in that case, the amplification or the line signal level of the audio going to the radio is a separate subject than is the equalization, because here we're playing with the difference in frequency range. So we're amplifying this particular frequency range, in this case by 20 dB, but that doesn't necessarily mean that we're changing the overall signal level or the amplification, or in radio terms, the gain for the microphone. So of course, if you're overdriving that transmitter, you need to decrease that gain. So to sample that, or do an example of it here, we'll drop the gain of our signal. We'll take that back down to 0 dB, and there you should still be able to hear my audio, although it has decreased quite a bit. And going back to QSB or fading signals on sideband, if you do have a fluctuating signal, then this will give you an example of how that plays into, again, the intelligibility of you over top of whatever band noise that is the station is hearing that you're trying to work. So we'll go ahead and bring this back up. I think I had that set at 5 dB, I believe. And again, you'll see that my audio rises quite nicely over top of the receive audio or the band noise that we have from the 718. And just to go back to the point of the equalization, if we take our mid-range and drop that back to 0, we have no artificial equalization period. It's just flat across the whole band, the audio band that is. Then you can see that my audio tends to drop back down amongst the noise, and the intelligibility decreases as well.
So let's do another transmit example. And this time I am transmitting live from one radio to the 718. I'm going through a dummy load on the transmitter, so I'm not transmitting completely live on the air, but I am transmitting with an SSB signal and receiving it on the 718 on SSB also. This is lower sideband because we're going through 40 meters. So just to prove the point, I'll change the frequency of the transmitter, and you'll see my audio change with that. So you can see we were on the RF side, not just the audio this time. We're actually playing with the audio going through an RF signal. So with that having been said, let's go over to the equalizer. And again, my point number 2 is going to be our sweepable mid-range. You can set any one of these points up for however you want that set to. A little bit more info on the transmitter. It's a TS2000. I have the transmit bandwidth set to 2.8 kilohertz, and I'm using the same Heil headset with their typical wide range element. It's not anything like the DX element or anything. It's just a normal conversation element. So let's take this mid-range frequency. Right now I have it set to 2.04K, and we'll go ahead and increase the gain on this. We'll go up to maybe 5 dB. Let's see how that sounds. And then, in fact, we'll go ahead and go up to 10 dB. Why not? And again, since we're receiving live on 40 meters, there's some band noise. There's some kind of a pulsing noise in there that's in the background. And if you have sensitivity to higher frequencies in your hearing, you might hear some QRM from other stations and a higher pitch frequency there. So we'll go ahead and sweep this mid-range. I'll drop that down in frequency first, and then we'll go up higher in frequency. Testing, 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 testing. Testing, 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 testing. Testing, 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 testing. And there we're about 3K. And then we'll drop it back down to say 2.5K. So there's about 2.5K. And we'll drop it down to 2K. And we'll drop it down to 1.5K. And back down to about 1K. And then we'll take the gain and drop that back to 0 to flatten it back out. So now we've got the gain flattened out, and this is just the bare microphone element by itself. And just to prove the point of the mid-range helping out with the intelligibility over top of the band noise, we'll raise this back up to about 2K, and I'm going to bump the gain up to, say, 5 dB this time. So you can tell above the band noise there that it definitely helps out having that mid-range frequency boosted in gain or sensitivity. So again, you can't necessarily take the microphone and unplug it from your radio and stick it in the ear canal of the station you're trying to work. But by tuning the equalizer on your transmit signal, you do have the chance to get over top of some of that band noise.
We talked about using the UI-24r with digital modes earlier, so that's what we're doing now. I have FT4 running on the computer in the background. That's EB2AM, Echo Bravo 2 Alpha mic. It looks like I'm working at the moment. Let's see if this comes through here. There we go, we just completed that QSO. Go ahead and stick that in the logbook. But we're using, of course, the UI-24r as the sound card interface. Then I have the same EasyDigi box with a USB to serial adapter going through the DB9. That's what we're using to key the PTT. And then as I showed earlier, the 13-pin DIN connection on the back of the ICOM 718 is what we're using for both audio in and out and the PTT keying. So that makes for a pretty clean install. You don't have the cables on the front of the radio. But on the computer side, what I have set up is we'll go into the sound settings here first on the computer end of it. And for the output, I have line out 1 and 2 selected. You have up to 32 available, but we're just dealing with 2-channel typical stereo left and right, so that that goes through 1 and 2. And the same thing on the input device. We're using the same 1 and 2 for a mic or line input. We go back to the WSJT software side of it. Settings. Let me reset this here. There we go. Go into settings. Go to audio. You'll see that the same input and output channels 1 and 2 through the Soundcraft mixer are what we have selected. And then for the radio input for the keying, that USB to sound card, or USB to serial adapter, I'm sorry, is going through COM5. And we have our RTS selected as the keying type. So if we hit our test BTT, you'll
see that that enables, and it's set the radio into transmit mode, and then we can disable that again. So it all works just fine. So this way, again, if you're using the UI-24r with a microphone, there's really not a whole lot else to do to get it to run with the digital modes. You just maybe use a different channel to route the audio through back to the computer. And of course, you're not, well, in my case, if you look at the waterfall display, you'll see the mic audio is actually feeding back into that, because that channel 1 and 2 on the input is reading off of the master output of the mixer, which I have both the ICOM 718 feeding through as well as the microphone, just so I can record the audio combined to put in this video. But typically, of course, if you're running digital modes, you wouldn't be using a microphone. It'd just be strictly the audio from the radio into the computer. So I hope that squares things away on the digital mode aspect of how you can make use of the UI-24r mixer. That covers all the bases that I wanted to talk about in this episode. Again, the UI-24r mixer is extremely powerful and flexible with amateur radio communications. Going into the parametric equalizer, both on the transmit audio side and the receive audio side. Again, the real name of the game there is intelligibility of speech, and considering that 1 to 3K range is most important for making that happen. Using that parametric equalizer, we're able to boost that both on the receive side as we're hearing the stations we're trying to work, as well as on the transmit side to boost that audio going back out to the station that we're trying to work. So again, you can't really unplug that microphone from the mixer and then stick it in the eardrum of the station that you're trying to work. But if you use all the principles that we talked about in this video, the clean audio, taking out the hum from your transmit signal, all of those things, and then boosting the mid-frequency range, you can certainly give yourself a fighting edge that would be more so than just a standard microphone. So definitely a lot that you can do with it. And again, the last segment we covered digital mode operation using the UI-24r as an external sound card. It works pretty good too. So again, it's not just limited to voice audio. It's really anything audio related. Again, the Easy Digi, that's a really neat circuit board that you can use for both audio in and out, and then PTT, or in this case, the serial connection for the PTT keying. So there's again just a lot that you have available with the combination of using a mixer and the Easy Digi, etc., to get your computer and radio hooked together, microphones, all of that. So speaking of the microphone, I'll talk about that for just a quick second. Again, that's the Roswell Mini K47. So check them out. I'll put a link to Roswell Pro Audio in the description of the video below. So I hope you enjoyed this video. I certainly had fun putting it together. It's interesting to go through with all the different mixings of channels and things. There's some of that that we went over in specifically the receive audio, that and the transmit audio that I didn't talk about, but I did route a lot of the audio back out of one of the auxiliary ports and then back into a channel. So we didn't talk about that too much, but I'm sure if you dig into the settings, if you've got one of these, or pick one up later on, you can figure that out. But definitely a lot that you can do with all the inputs and outputs and how you can tune things. So that's about it. If you like this video and it's helped you in your own amateur radio endeavors, then click the bell icon down below and hit the link for notifications. That way you'll get an email the next time that I post a video. My name is Steve, and my amateur radio call sign is KC8QVO.
You can also follow me on Twitter at QRP to QRO. Thanks for watching.